Hey guys, just wanted to do the check your understanding, go over the homework that you had from the 6.7 so that we could talk about that. Now, the big thing here with this first question is a lot of times, you get a little confused because you're like, well, they didn't give me W prime of t because you're so used to doing the area under the curve. And so when you look at this, you initially think you don't have enough information, and you guys aren't quite sure what you're doing, maybe you try to graph W of t and then look at area for that. But what you have to remember, this is the second part of the fundamental theorem. So by FTC, the second part says that the definite integral from 0 to 20, where the rate function is inside of the integral, can be calculated by simply doing the net change, your net change in your W of t function that you would have. So looking at the net change in the antiderivative or the accumulation, the displacement. And so the idea is that you're using the values from the table. So we're pulling out the value for W of 20 over here at 71 and 0 over here, 55 here at 0, and then calculating your net change from that. So that's something you do want to watch for, that if they are giving you the values of the original function in the table, but yet they are asking you for the definite integral, that they're asking you for displacement on that. Then for number two, we went back to this idea of finding the antiderivative, the actual function value, incorporating the starting value. So this is that idea where there was a constant that gets added to this. And the way that we figure out that what that constant is going to be using definite integrals is we remember that where I am currently is equal to where I started plus the net change from that starting position. And so you do want to remember, again, this is the other part of FTC, that this idea of accumulation and finding function values can be done by taking where you were plus your net change from that position. And so g of -2 was given to us right here. And sorry, I get distracted. There's probably a bunch of emails going on right now. So I calculated the g of -2 was given. So that's where I got the -11. And then over here in the picture that you had a picture of your rate function, g prime. And I basically calculated the area of each of these little sections. And I needed -2 to 4. Everything was above the x-axis. It was all positive. So I simply added them together to get the 2 pi plus 2. And then I just simplified it down. All right, multiple choice wise, you do want to make sure when you're looking at it that it's just this idea that you have to watch for these questions where they're asking you for a function value, because that function value typically, when they say it's an antiderivative, that means it's not the quote unquote accumulation function. It's the where I am is equal to where I was plus where I started. So you always want to remember to include that if they haven't defined g of x as just the integral or the accumulation function. Typically g of x is going to be the function with the constant added in, which means you have to add in the initial condition for that. And so that's why our answer is 5. It's where you were at 3 and then your net change from 3. Talking about why these are not kind of eliminating the other choices that are down here. The 3 to 8 here for B does not include the initial condition. So that one's out. This one, you kind of think they may have included the initial condition. Oh, I realize, I apologize, I'm not on the screen. All right, let me back up a second here since I realized I forgot to scroll up. What I was looking at here was when I was talking, initially, like where you are, g of 8 is where you were, initial condition, and notice that this value down here at the bottom bound has to match the where I was, because I want the net change from where I was, 3, to where I want to be, 8. So they match up whenever you're doing this. Notice the 8 and the 8 right there. They should match. Um, and so that's why the correct answer is D. Now, I was talking about why other answers are not correct. B is not correct because it does not use the initial condition that was given at all. That's just the net change. And when you are finding an antiderivative given g of 3 is 5, they want the particular or specific antiderivative with the constant found. So you have to include this initial condition in that portion of it. Here in C, my point here is you start to think, well, maybe they did include the initial condition. But remember, you can't just pull a constant out of these two things. C and D are not equal to each other because the rule for sums in a definite integral is really that this is the same as 3 to the 8 of 5 dx plus the integral of 3 to 8 f of x dx. This integral right here is not going to be equal to 5, that initial condition. Remember, that's equal to 5 times 8 minus 3 because it's a rectangle. So that's why that one's out as well. And then A, hopefully you would realize that that's totally not even a choice. It didn't ask for the derivative of f of x. It asked for the antiderivative of f of x. So just paying attention to that phrasing that's there. And then for 4, 5, and 6, those are fairly straightforward. And it's just this idea that each time that you are calculating a definite integral algebraically, what you're doing is you are first going to calculate an antiderivative. And we pretty much always use the antiderivative where C is 0. Mostly because we don't care, C is going to cancel out anyway, so why don't we just go with the simplest version that we have? So we find an antiderivative, and then we basically calculate our net change. And the one mistake that I do see from students that I want to kind of highlight this, make sure that as you are looking at it, this is the end, and this is the beginning. And so when you are looking at this, you always want to do, when you're doing your net change, it's end minus beginning. Because if you do that in the reverse order, you're going to have a negative where you shouldn't have a negative. So just want to pay attention to that. You basically plug your ending value into your antiderivative, plug your beginning value into your antiderivative, and subtract. So that's pretty straightforward for that. So that'll wrap up our 6.7 using the definite integral and the kind of the algebraic way of calculating them, which is the idea that we are going to calculate using the net change. So two main ideas. I'll come back up here to the summary up here. The two main ideas out of this is that algebraically, to calculate a definite integral algebraically, find an antiderivative and calculate the net change. Okay. And then the other part of the fundamental theorem of calculus that's very important is that to figure out where you are, it's equal to where you were plus your net change. Now I am going to add one more thing here. Okay, so that was one, this was two, main idea that is there. So when we look at that, then the third thing is, and I'm going to create this because this is specifically two talks about finding a function value versus finding a function. So now I'm going to rewrite this as f of x. So to find the specific antiderivative, what you are going to do is you're going to take where you started, so that's the same, plus your definite integral from that starting point. So the a should be there. But now I don't want to pick a specific ending value. So instead of putting b, I'm going to put x because what's here and here should match, okay? So I wanted to keep that in general. I want my variable to be the upper bound. And then inside of the definite integral, because I already used x there, I'm going to switch this to f of t dt. And so that way, and remember that's just a placeholder variable to hold the place inside of the definite integral until we calculate those things. And this obviously should kind of make sense to us anyway. if you think about the first one up here, that technically, if I was calculating this with an antiderivative, this would equal the antiderivative with x plugged in minus the antiderivative with a plugged in anyway. And so f of a minus f of a would cancel out. And of course, it's going to be equal to f of x. But I just wanted to kind of show you that as well for our third thing. All right, so that's going to finish up our check your understanding for 6.7. I am going to have some Zoom classes on Friday, so be looking for the sorry, I lost my train of thought. So be looking for some information about the Zoom classes coming in. I would like to get everybody there. We're going to talk about what consequences there are from what's coming from admin. You guys should be receiving a email from Dr. Lowry shortly, and then I'll start adjusting and doing what I need to do based on the information that comes out from them today. So everything's kind of in flux right now. We're all trying to figure it out. We will do the best that we can for you guys. I do also want to show you one more thing before I end this video. Hold on, I gotta move myself over here. I did add in for everybody. I don't know why this is not updating. Let me see. Oh, I'm offline right now. But check in the program. I can't show you on this computer, but in OneNote, there should be another over here. I don't know if you can see my cursor. I added another section down here below the integration unit, and that is going to start being where I house AP review material. So I've started adding some things to that. All right, so I will see you guys face to face in Zoom on Friday. The fourth period and fifth period, we'll kind of do it at your class times. Eighth period, I'm going to push it to 3:30 because I want to do it after the AP class on the differential equations, the 7.3 that's there. Don't forget that those are coming up starting tomorrow at 2 o'clock each day. There's the 7-1 differential equations, 7-2 is solving differential equations, I think, and 7-3 is slope fields. So that takes care of the Unit 7 material. That is the last topic that we have for the test. All right, I'm going to go ahead and start working on the last topics that we have in Unit 6, which is the U substitution, working backwards from chain rule, and additional practice with U substitution and other integration techniques that we're going to have. All right, so I will see you guys shortly. Have a nice day.